In this video, I'm going to talk about projectile motion. So this picture shows the trace of a tennis ball after the ball was hit by a racket. So the trace is the curve of a parabola. Now the ball is a projectile. So the trajectory of projectile is the curve of a parabola. Using here, the trace show that it is the curve of a parabola. In fact, it is not a perfect parabola because of the effects of air resistance and Earth's rotation. For now, we do not consider the air resistance and the Earth's rotation. And this direction is horizontal direction. And this direction is vertical direction. And this picture also shows that the projectile motion is a 2D motion. The ball moves in both the horizontal direction and the vertical direction. And after investigation, people found that the projectile motion is the combination of the independent horizontal motion and the vertical motion. And the projectile motion has the following probabilities. Number one, the horizontal motion of a projectile has a constant velocity. Number two, the horizontal component of acceleration is zero. In fact, these two are the same. So the first one said that the horizontal motion has a constant velocity. This means that the horizontal motion does not have an acceleration. Or in other words, the acceleration of the horizontal motion is zero. So number one and number two, in fact, they have the same meaning. And number three, the vertical acceleration. The vertical acceleration of a projectile is constant. Because of gravity. In fact, the vertical acceleration is just called gravitational acceleration. And the magnitude of the gravitational acceleration is just 9.8 meters per second squared. And number four, the probability number four, the horizontal and the vertical motions of a projectile are independent, but they share the same time. Now, because the projectile motion is the combination of the independent horizontal motion and vertical motion. And the horizontal motion and vertical motion, they are independent. They do not affect each other. So when we analyze 2D projectile motion, we can separate the problem into two simple one-dimensional problem. One is the horizontal uniform velocity motion, and the other is the vertical uniform acceleration motion. Next, we introduce the equations about the projectile motion. So, for example, a projectile is released with the velocity vi, and we know that its trajectory is a parabola. Is like this. Is like a parabola, and its motion are 2D motion. It moves on the vertical direction and the horizontal direction. Now this is its initial velocity. The velocity vi, is it a vector or a scalar? This is a vector. But before, we remember that it is said that for a vector, there should be an arrow. There should be an arrow on top of the symbol. But now, this initial velocity, this is a vector, but there is not an arrow on top of it. Why is it like this? I think it's because of the symbol system the textbook used. So before, the textbook said that for a vector, we should put an arrow on top of it to show that it's a vector. But for the projectile motion part of the textbook do not put an arrow on top of the vector symbol. It's just the textbook does it in this way. So, but we just remember that now this is a velocity and it is a vector. But in the projectile motion part in the textbook, we do not put an arrow on top of the symbol. And the projectile motion is a 2D motion. And now we separate the 2D motion into two simple one-dimensional motions. So now we draw like this way. We find the perpendicular components of the initial velocity. So this is the initial velocity x. This is the velocity for the horizontal motion, and this is the initial velocity y. So this is the initial velocity for the vertical motion. This angle is theta. The theta shows the direction of the initial velocity, and this angle is a right angle. So from here we can know that the initial velocity x, so the horizontal initial velocity just equals the initial velocity multiply cosine theta, and the initial velocity for the vertical motion. So the initial velocity y just equals the initial velocity multiply sine theta. Now we introduce some formulas for projectile motion. We already said that the projectile motion is a 2D motion, and it is a combination of two independent one-dimensional motion. These two motions are, one is the horizontal motion and one is the vertical motion. And the horizontal motion has a constant velocity and the vertical motion has a constant acceleration. So the projectile motion can be separated into one is horizontal motion and the horizontal motion has a constant velocity, and the other is a vertical motion, and the vertical motion has a constant acceleration, and its acceleration is just the gravitational acceleration, and we use the letter g to represent it, and this equals 9.8 meters per second square. And now I draw its initial velocity here again. This is its initial velocity. We add initial velocity. And this is its horizontal component via x. And this is its vertical component via y. This angle is theta. From the graph, we can know that the initial velocity x, and this is the horizontal velocity. The horizontal velocity just equals its initial velocity multiplied cosine theta. And the velocity for the horizontal motion is a constant. This velocity does not change. So its velocity is for the horizontal motion, its velocity is always Vix. So Vix is a constant. This does not change. The horizontal velocity does not change. Now, the horizontal displacement is just equals the initial velocity for the horizontal motion Vix multiply delta t, the time interval. And this equals, because the horizontal velocity equals the initial velocity multiplied cosine theta. So here is like this way. Initial velocity multiplied cosine theta, now multiply time interval delta t. And now for the vertical motion, the vertical velocity, initial vertical velocity Viy just equals the initial velocity multiplied sine theta. And we have this one. The final velocity for vertical motion equals the initial velocity for vertical motion minus the acceleration g multiplied delta t, and it also equals, because the initial velocity for vertical motion Viy equals the initial velocity multiplied sine theta, and here minus d multiplied delta t time interval. And the vertical displacement just equals the initial velocity for vertical motion multiplied delta t minus 1 over 2 g multiplied delta t squared, and equals, because the initial velocity for vertical motion is the initial velocity multiplied sine theta. Here is initial velocity multiplied sine theta multiplied delta t minus 1 over 2 multiplied acceleration multiplied delta t squared. And another formula is the final velocity for vertical motion squared equals the initial velocity for vertical motion squared minus 2 multiply the acceleration g multiply the vertical displacement delta dy. And this equals, because the initial velocity for vertical motion Viy equals the initial velocity Vi multiplied sine theta. So here is its square minus 4 multiplied g multiplied vertical displacement. Now we check the formulas for the vertical motion. We learned this formula before. The final velocity equals initial velocity plus acceleration multiplied delta t. In fact, this formula is different from this formula. The left side is the final velocity, and the right side is the initial velocity. Here is plus acceleration multiplied delta t. Here is minus acceleration multiplied delta t. Why here is minus? It's minus because for the formulas of the projectile motion, we define the up direction, also the y direction is the positive direction, and the x direction to the east, this is the positive horizontal direction, positive x direction. So the up is positive, and to the right is positive. But the actual direction of the gravitational acceleration, its actual direction is down. So its direction is opposite to the positive direction up. So here is minus. And also we know this, we learned this formula, delta d equals the initial velocity multiplied time interval delta t plus 1/2 multiplied acceleration multiplied delta t squared. In fact, this formula is different from this formula. You see, the left side are all displacements, and here is initial velocity multiplied delta t. Here is also initial velocity multiplied delta t. Here is plus 1/2 multiplied acceleration multiplied delta t squared. Here is minus 1/2 multiplied acceleration multiplied delta t squared. The difference is that here is plus, here is minus. The reason is the same as the formula above. It's because the actual direction of the acceleration g is opposite to the positive direction up. So here is minus. And the actual direction of g is down. We also learned this formula. The final velocity square equals the initial velocity square plus 2 multiplying the acceleration multiplying the displacement. In fact, this formula is different from this formula. From this formula, we differ this formula. You see the left sides are all final velocity square, and the right side are initial velocity square. Here is plus 2 multiply acceleration multiply displacement. Here is minus 2 multiply acceleration multiply displacement. Where here is plus, here is minus. The reason is the same as above. It's because the direction of the gravitational acceleration is down, but the positive direction here is up. So the actual direction of the gravitational acceleration is opposite to the positive direction. So here is its minus.